There is nobody in the waiting room. You're good.
Good morning, everybody. Welcome to the 2020 North Central Regional Cooperative Soil Survey Workshop. Welcome to the Show Me State. The organization of this event has been a collaborative effort from my staff, the University of Missouri, and the U.S. Forest Service. I would like to thank Dr. Samuel Indurante, NRCS, Dr. John Kayrick from the U.S. Forest Service, and Patricia Quackenbosch from the University of Missouri for the great effort on the logistics of this conference. I would like to thank Mark Amney and the MLRA Soil Survey staff for all the hard work on the preparation of the field tour. I would like to thank Douglas Wallace for his assistance on the field sites, and to Lydia Verbrugge, who has been serving as acting state soil scientist during my assignment to the National Soil Survey Center. Special thanks to Curtis Munger, our national leader for soil survey standards, for keeping us on track, and to our new state conservationist, Scott Edwards, for his unconditional support to the conference since day one. Also, I would like to thank our partners from the Soil Health Assessment Lab, Dr. Steve Anderson, Donna Brandt, and Ross Dresbach, which conducted the full characterization of the soil profiles for their biological, chemical, and physical properties. Finally, I would like to thank to all the speakers and poster presenters that accepted our invitation. We share a common vision of the conference theme, measuring soil ecosystem responses in a changing climate. It's very important that this event is an enjoyable and not stressful for anyone. We know it can be tiring to be in on all day in a virtual meeting. I would like to invite us not to say sorry or apologize if a pet, family member, or bottom at the end, you can turn off your video. We are all doing the best that we can within the new normal. We will be recording all the meetings in the general sessions. If you have questions for the speaker, please send them to muconf9@missouri.edu and reference the speaker or session. Those questions will be provided to the moderator at the appropriate time. Everyone should have the agenda. Will obtain the Zoom links for each breakout session Tuesday afternoon. You can leave one and join another one if you are interested. The moderator will be explaining how the field tour will be conducted later on. Posters are linked to the MU registration website. Please take some time to review their research. And thank you, everybody, for joining us, and enjoy the conference.
Good morning. I am Patricia Quackenbosch, but nobody calls me that. I go by PQ. A lot of you probably know who I am. I am an instructor in the School of Natural Resources at the University of Missouri, and it's been a pleasure working with my colleagues across various institutions to put this conference together. I really wish we could have all met in person. It's much more fun to talk about soils when we're actually out in them rather than in front of our miscellaneous screens. So hopefully in the near future, maybe we can all find a time somehow, somewhere to get together. But yeah, no, I just wanted to welcome you to, I guess, sort of the University of Missouri. At least we're hosting the conference out of here. The University of Missouri has a big history with soils, and I'll let my director talk more about that. But it's nice to see that the soils conference has kind of come home to a place where some of the biggest movements forward in soil science have happened at the University of Missouri. So without further ado, I will pass it off to Dr. Pat Market.
Good morning, everybody. Might be a little out of order here, but that's okay. My name is Pat Market. I'm the interim director of the School of Natural Resources, and I'm pleased to be able to be the host institution for this event. My only regret is that you won't be able to be here in Columbia or on the MU campus. I would like to extend my deep thanks and appreciation to all of our participating entities that have made this happen: the USDA, the Forest Service, NRCS, Missouri DNR, and of course PQ, who just spoke to you. Very happy to have her as part of our faculty. I'll be honest with you, I'm a meteorologist by training, but I've been here for 20 years at MU, and in that time I've learned a number of names which I'm sure you're all familiar with. Marbut in particular, who was a director of the Missouri Soil Survey and later went on to be a director of the USDA Soil Survey Division. Albrecht, who's well known for pioneering work in soil health. Also Dooley and Miller, for whom the Dooley-Miller plots are named on this campus, and their pioneering work on soil conservation and soil erosion prevention. There are a number of others, of course. Marshall, Jenny, Smith, and Sauer. I don't want to take up too much time. I know that you all are all quite familiar with those, and more so even than I am. But it does speak to the long history of soil science here at MU. In that same fashion, I'm sure you're all familiar with Sanborn Field. Just would point out that turned 130 in 2018, a large celebration here at MU that was led by Tim Reinbott, and we're appreciative of that. Of course, probably the single thing that everybody associates with Sanborn Field, both inside and outside of soil science, is the discovery of Aureomycin in the late 1940s. There was mention of the shack already. The Soil Health Assessment Center that had its roots in 1985 as the Soil Characterization Lab, which was originally funded, I believe, by Missouri DNR. And in 2015, it did find its new home on Missouri South Farm. And I believe there's going to be an extended YouTube presentation on that here later today or tomorrow. And those soil characterization services continue. I just close by saying how grateful I am to the soil science people that we have here on campus. There are a number, but specifically in the School of Natural Resources, and who continue to deliver some teaching, our teaching, not some teaching. Steve Anderson, of course, PQ, who you just heard from again. We do have a couple of new additions, or one, I should say, Morgan Davis, who just came to us from Iowa. And then also I was asked to give a brief update on the soil health search, and that is ongoing, but unfortunately, as so many places are experiencing nationwide, we've made it down to a final 4 candidates, and I think we still have 4 candidates because nobody else is hiring right now either. So until we're able to have people on campus, that comes from the very highest levels of MU administration. They want everybody to be able to look at MU and for us to have an actual look at them as well. So that is on hold at the moment. That's entirely COVID related and not because of anything else. So with that, I don't know who's up next, but welcome to MU, and looking forward to watching some of the conference with you.
Thanks, Dr. Market. I'm Sam Naranti, and I'm the moderator for the morning session. And I'll introduce the speakers, and it'll be a very brief introduction. And I'll start out with Scott Edwards, and he's the Missouri State Conservationist here in Columbia, Missouri, and he'll give you his welcome.
Thank you. So I'm Scott Edwards, and as the state conservationist here in Missouri, I want to welcome everybody to the virtual conference. There's 2 things that I know having to switch to virtual. I think we've got more people that are actually going to be able to attend, but this will be the first time you've ever taken a field tour in August in Missouri and been able to do it at 72 degrees, climate controlled. So that is one positive for later in the week. And early on, it sounded like a NASA launch as the organizers of this meeting were pulling everything together. It was very, very impressive how we've all had to adapt to this. But in Missouri, I think the thing that has made everything so successful in our programs of we also have the 1890 institutions, Lincoln University, ARS, U.S. Forest Service, and then our state partners, the Missouri Department of Natural Resources and the Department of Conservation. But I want to highlight some of the things that I think that have made the partnership so successful. Missouri, back in 2018, was the first state to get all of the statewide ecological site descriptions finished, and that couldn't have happened without all the hard work from the NRCS employees, but also this larger partnership. The Missouri Soil Health Initiative and that work that has been going on for quite some time between the agency and working with our soil health specialist and that activity that's happening, and mentioned earlier the Soil Health Assessment Laboratory. But then something new is the Soil Climate Analysis Network, something we're calling SCAN, but it's taking those ecological site descriptions and trying to merge that with the climate information to help us have a better understanding of the changing climate and how that's impacting our producers here in Missouri. Starting in 2002, with just 4 stations, we've expanded that now to 13 stations in Missouri. And so I think right now with the theme of this conference, experiencing with the severity and just the changing day-to-day issues that we're having around climate, I think this is going to help put us in a place to, again, help our producers move forward. But the Missouri Soil Survey is over 100 years old. And when you think of where it's come over those times, very often the very first, from consultants to producers to our field office staff carrying those hard copies around. And that's when people ask me what I do for a living and they have no idea of the background of the agency. You can usually get them to something like the Soil Survey. But then as this group has evolved over time and now moving all the way forward with a very modern version of it, and then the Soil Survey. Hang on just one second. I think we're having some technical difficulties. This is great. Okay, sorry. So now moving all the way to Web Soil Survey, but one other thing that's impacting our NRCS field offices is as our agency has evolved and becoming more focused on having to deliver the programs that we have each year. The agency a couple of years ago set forth with developing basically a new planning and ranking software. And it brought together all divisions of the agency as we move forward. But the soil and plant division was really leaned in and provided that wealth of information and the big data that we've had in that agency, but making it move over into that new software. And without that kind of impact, that would not have been successful, and we would not be able to do the delivery that we have now on the ground. And so it just goes to show that being one of the original pillars of the agency starting over 100 years ago here in Missouri, but then evolving and changing with the times and getting to where we are today, you're still having an impact, and that's very important. And so I think this workshop is going to highlight liberation that we've already had, but then how can we look forward into the future and to continue to deliver? So again, welcome. I know it's virtual. Been nice to be able to meet with you and get out in the field, but we'll do the best we can with the virtual conference. So hope you have a successful conference. Thanks.
Thanks, Scott. Next speaker is Dr. David Limbo, and he's the director of the Plant and Soil Science Division, and he's going to give his welcome. It's all yours,
Right.
David.
All right, thank you, Sam. Hopefully you can hear me. So I am going to be talking later, so I'm going to make this presentation or this welcome very brief. Again, thanking you all for being here as part of the Cooperative Soil Survey. I do want to point out, though, as far as the Cooperative Soil Survey, this is perhaps one of the best times for the Cooperative Soil Survey, and it's an important times because of the way our budgets look. So it means that we absolutely have to cooperate more in order to get more bang for our bucks. So I appreciate everything that we're working with our federal partners, our state and university partners, private sector, and we are reaching out to private sector more and more. We're also reaching out to the national academies. So the National Academies has soils on its agenda, and hopefully in March of next year, when we can all meet face to face again, there will be a meeting at the National Academies on soil information. And again, that should be a pretty interesting conference. It will be international, and that has to do with a lot of our work that we've been doing with the Global Soil Partnership, with FAO, again, working with them for soil information, but also working with them on their lab testing to making sure that we have similar standards for laboratories across the world. So in many ways, this is a wonderful time to be part of the Cooperative Soil Survey. So I thank you all for being here, for listening. This is a fantastic agenda. I'm really looking forward to the field trip. 72 degrees this time of year, and seeing Missouri, you cannot beat it. So thank you guys for arranging for that climate controlled event to look at soils. So with that, thank you, Sam, and the rest of you organizers. Great job so far.
Of Soil Survey and Resource Assessment for USDA NRCS.
Hello. Thank you very much. Good morning, everyone. My name is Louis Tupas. I am still the relatively new Deputy Chief for Soil Science and Resources Assessment at NRCS. I came to the USDA National Institute of Food and Agriculture, where I started out as the first national program leader for global climate change, and then became the division director and moved my way up to being the deputy director for bioenergy, climate, and environment. So I'm really happy to be here to join you for this very important workshop that you have right now. So I am sharing my screen right now, and I hope you see the slide of what is a pedologist. Do you see that?
Not yet, Dr. Tupas. You want to try that and push the share button, maybe?
Yes, I did, and I thought I did. Stand by. I'm going to do that.
You are fine.
Again.
We have a little bit of extra time. I'm sure everybody would like to
All
see
right.
that.
How's that
There.
now?
Perfect. It's up.
Do I see? What is a pedologist? Okay. Thank you very much. And just as a short introduction, because Professor Marquette said that he's a meteorologist. Sir, I am an oceanographer by training, so you're in good company. So really, I'm happy to be here because the topic of your workshop is very dear and dear the past 30 years. It is important for our current and our domestic and global situations. But rather than talk about the importance of the theme, which is measuring soil ecosystem responses in a changing climate, I would like to focus on the professionals that do the measurements and accomplish the studies, specifically the soil scientists. So as the slide shows, a soil scientist, also known as a pedologist, is a person who is qualified to evaluate and interpret soils and soil-related data for the purpose of understanding soil resources as they contribute not only to agriculture production, but also how soil is managed for protection of human health and the environment. The knowledge and skills include an understanding of the soil ecology, its environment, including soil morphology and soil forming factors, soil chemistry, soil physics, and soil biology, as well as the dynamic interaction of all these areas. Sorry. Changing slides. A soil scientist is expected to add to a body of knowledge, but there is a new paradigm where the soil scientist is also the practitioner of that body of knowledge. That knowledge is used for evaluating the impact of human activities and climate, for example, on the soil ecosystem, and making decisions for the use of soil resources. Professionals with degrees or skills in soil science are now pursuing careers in various basic and applied sciences and are becoming prominent members of interdisciplinary group, both natural resource management and environmental quality issues. Soil scientists also need to be recognized beyond their scholarly and technical achievements. Soil scientists must be acknowledged as responsible, accountable professionals amidst other practitioners of science and engineering for the proper management and use of our soil, water, and natural resources. The applied practice of soil science must be done by professional soil scientists. This will result in increased involvement of soil scientists in resource management and planning the capabilities of soil scientists and educating the general public and professionals in other disciplines to the value of soil science. When a state, city, municipal, or county group is organized to address an agriculture issue, one of the first questions should be, is there a soil scientist in this group? Here is a picture of Dr. Ratan Lal, a professor of soil science at the Ohio State University. And he is this year's recipient. A soil scientist for over 50 years, Dr. Lal, who is the director of the Carbon Management and Sequestration Center, has pioneered farming techniques that prevent soil from losing these vital nutrients and even put nutrients back into soil. He is a great example of a scholar, a mentor, teacher, promoter, advocate, practitioner, and a professional soil scientist. Dr. Lal also epitomizes Dr. Norman Borlaug's philosophy that science is meaningless if it does not serve humanity. So as you advance the work of measuring soil ecosystem responses in a changing climate, use this opportunity to advance the recognition and profession of soil scientists. Climate scientists do not have as great an impact in changing behavior as you have. You can demonstrate the impact of your work. Use what you have, use what you know, use what you measure to serve humanity. Thank you.
Next come the reports from the MOs and the regions. And the first one is Chad Remley, and he's Region 5, and he's going to give his update. So it's all yours, Chad.
All right, thanks, Sam. Hopefully everybody can see my screen, please. Somebody acknowledge me. Yes?
Yes,
Okay,
sir, I can see your screen.
Thank you. Okay, so this is an update for Soil Survey Region 5, Central Great Plains. Central Great Plains takes part of the eastern part of Montana, Wyoming, Colorado, and states of Kansas, Nebraska, South Dakota, and North Dakota. We have 15 active offices. Currently, there's a total of 17 offices, but currently there's no staff in Devils Lake or Garden City, and 37 employees. I want to spend a little time talking about the types of the MLRA office projects that we've been working on. We have a fairly diverse group of projects. First is the evaluations. Each of the staff do 10 evaluations. These are attribute data. We're taking a look at, as you know, the original soil survey was mapped by soil survey area or county project, and each county was separately from the adjacent county, even though they used a similar map units. And through evaluation process, we're blending those and finding MLRA projects to work on from that. MLRA projects are on-site investigations. These are projects that come from customers, whether it's a suggestion by the state soil scientist or area resource soil scientist. These are the projects that the MLRA field staff are going out investigating on site. It could be there's a myriad of different projects. Benchmark projects, kind of a new style of project we're trying, where it's the Hayes office in Kansas is looking at the soils. They're looking at every single map unit. It's a multi-year project. We're looking to refine the OSD, official series description, and taking a complete and thorough look at the Roxbury series. We have some denied access mapping access in Wyoming and Montana. We've been able to, due to changes in landowner, get back on some of the property that we previously missed. So we're doing a little bit of initial mapping. Andy Steiner in Fort Morgan is currently working on the city of Denver, mapping that. There's about 63,000 acres in the city of Denver that was never mapped, and we've been able to work through with the city of Denver to get permitting to work on that. Dynamic soil properties. There's been a national bulletin that's come out along with a national instruction. All of the MLRA offices are conducting a dynamic soil property project, whether it's part of an MLRA project or it's a separate standalone project. We have several in process. Dynamic soil survey, that's a new process that we're undertaking, where we're taking a more comprehensive involvement and looking at the hydrology, all the temporal soil properties, DSP properties, and trying to enhance our interpretations. We have a project here in Clay County, Kansas that will begin. We purchased 4 H flumes and be looking at the whole hydrological cycle and looking at infiltration, just being a very comprehensive, intense project. We also have 2 agreements with the Bureau of Land Management for ecological site descriptions, one up in Havre, Montana for sage grouse, and another out of Miles City for land conservation planning. Provisional ecological sites, we were challenged 5 years ago to get them all to at least to the provisional ecological site level. To make that goal, we only have 58A and 62 left. We have all the provisional ecological sites finished. We have 5 ecological site specialists within the region. Kimberly Diller and Pueblo just recently retired July 31st, but they've done a great job in addressing ecological sites, and this is our 5. So far this year in 2020, we have spent 4,091 hours on technical soil services. Most of it's related to on-site investigations or technical consultating on conservation plans or before. We did spend some time on soil judging and teaching at schools and field days. Unfortunately, with the coronavirus, that's a lot of those different, might have been a greater percent, but we've not been able to do some of those activities. Laura Craven and Pueblo, however, did put together a virtual soils training day for schools, so that's been quite successful. We're still doing on-site investigations year-round. This is Andy Steiner out in the field. This was a shallow wetland area, intended to be a shallow wetland area, and unfortunately the pond, they didn't have the soil science come out first, excavated the area, and there wasn't enough clay liner to hold water. So when you're doing projects, please invite the soil scientist. Like Louis suggested, there's need for the soil science to be there. Bring them back to the soil monoliths. We think it's a great educational tool. We've come up what we think is a nice way to do a presentation with the soil monoliths using a 3-inch core, putting them into a frame. This allows a nice teaching tool. We've also been able to purchase soil tunnels This is an inflatable soil tunnel. We have 8 of these stationed around the region for teaching the soil forming factors. We also have 4 fabric soil tunnels. They're a little bit more expensive. The only downside to the inflatable soil tunnel is that you have a blower that constantly makes a lot of noise. So they're much better for the outside than they are for the inside. The other thing that we're bringing back is the block diagrams. Time Warner has been instrumental in getting staff to work on our block diagrams. We were incorporating the ESDs into the block diagrams. So we have parent material, the ESDs, landform, and the soil series. Trying to develop these, and they're color great teaching tools for students and young soil sciences. Digital soil mapping, will be providing this product with the city of Denver. My region is a little behind some of the other regions, but we're trying to catch up in this aspect. David Jalali up in Rapid City will be undertaking one of these projects in 21. So we're working through this, moving from Polygon to raster, but it's a new product for us. Some of the things we did get completed was updates for tabular updates and NASAS for NCCPI, National Cooperative Productivity Index, and we were able to get a lot of fixes for the Conservation Assessment Ranking Tool, CART. We've been able to keep up with that, and those updates went up with the July 1st refresh. We have a mid-infrared spectrometer in Salina. We were one of the first offices to get one. There'll be a couple presentations on some of the data. The great thing about MIR is it's a relatively fast, inexpensive way to have analysis of your samples. We've had good results on carbon. We're getting better results on pH and clay. We've processed about 700 samples in the Salina office. And when you look at it, takes us about a week to get results compared to sending samples into the KSSL, where you're looking at a cost of $3,000 for a sample, and it may be 8 months or so before you get results. So we're very high on the MIR use. And with that, there's a picture of a dye study that we did on how water moves in soils. This is the application of 8 inches water. And then I have the staff that are associated with the regional office listed. Thank you.
Thanks, Chad. Next report is Dave Kingsbury and its Region 6 update. It's all yours, Dave.
Thanks, Sam. Let me get to it here. Maybe you could let me in on it. Is my screen showing?
Your screen is showing, but if you could go ahead and make that a presentation.
How's that look?
That is perfect. Thank you.
Good. Volume okay?
Volume is great.
Great. Hey, thank you very much. As Sam said, I'm the Soil Survey Regional Director for Soil Survey Region 6, the Central Appalachians and Eastern Plateaus, and actually it's soon to be split a number of different ways, and I'll get into that in a little bit. So presently we've got, we had 11 offices covering 18 or portions or all of 18 states. And since then, we've had some adjustments. Hot Springs is now aligned with the South Central regional office in Temple, Texas. And as you can see, Springfield is really the one large area that we have, Springfield, Missouri, in the North region. And London, Kentucky recently has been shuttered. We had a retirement there, but we have staff covering that soil survey area. And in the near future, well, I guess I'm not sure how far down the road, we're going to be migrating to the new regional, where we're looking at 7 regions. So as you can see, the Northeast and the Southeast, they take the lion's share of Region 6 in the future. And then North Central and South Central, as I mentioned, Hot Springs has already migrated to the South Central region. So a lot of changes in the future. Hopefully this will not happen too soon. Okay, so for FY20, the Soil and Plant Science Division priorities are pretty much the same as in 19, haven't really changed much. Three major components to it: soil and ecological site inventory, technical soil, cooperative soil survey. So the lower two, the National Cooperative Soil Survey, events like this help strengthen that. And this is actually the third regional conference I've participated in because we are at a crossroads of regions, it seems like. Technical soil services, we're handling everything that comes in. If a request is made, we've been handling it, assuming it's something that we can do, it's an appropriate request. So I'm going to really focus on the other four items under soil and ecological site inventory. Basically, completion of initial soil survey. The it's got a mind of its own. All right, products and also collaborating with our partners to develop and produce those. And then also we're increasing the collection of data for dynamic soil properties. And then last but not least, it's probably our main line, is acceleration of MLRA projects to develop national seamless coverage. And actually, correction, I'm kind of caught up in this. The regions those are the regions that we are currently at. So there's an effort to use the new names and everything. It's just been fairly difficult for Soil Survey Region 6 because we are split 4 ways. Okay, and in the future, we're really focusing on providing enhanced products for better conservation planning and partner uses. And the dynamic soil survey has been mentioned already. That's one of the areas that we're going to be expanding. So for our region, the completion of initial soil surveys, nationally, we're looking at the end of 2026. It includes both private lands, includes Alaska, and one of the items there is it may consist of multi-order or resolution surgo. And in the West and in Alaska, this is going to be an item that they really focus on. Have you? Can you still see my screen?
No, we cannot see your screen.
My apologies. All right. How about now? Oh, hold on. The thing it keeps advancing. I probably got off of it when I tried to back it now.
We can see your screen now.
Great. All right. I won't go back. Okay, so basically the use of multi-order or a low resolution surgo is an option that they'll use out west and in Alaska. A couple caveats though, that the products need to be suitable for conservation planning and the type of conservation planning that is common in those areas. So it may not be as detailed as many areas in, say, in the East, where conservation planning, they use a fairly large scale. And then also, we're mobilizing to meet the deadlines in all the regions because they're increasing details to complete the initial mapping. So we've got both boots on the ground and remote assistance. So staff actually going out west and others, they could be assisting with correlation and database, and they could be doing that from their home offices. And regionally, we've got really 4 areas that we're concerned with. Arnold Air Force Base was completed this fiscal year. The Hutta Wilderness Area, which is the largest we have in our region. It's about 35,000 acres. And we're starting that project. We've got staff that have been doing survey work down there just the last month and this month. Be a digital soil mapping project. So we expect a raster-based product at the end of that project. Fort Campbell, Kentucky, Fort Campbell in Tennessee, the Tennessee portion, that's going to be completed in FY22. and then City of Lexington, Kentucky in FY23. So we don't have a huge workload, but since we don't, we will be better able to assist in those areas that do have large areas of initial. So really, the Eastern regions should be able to complete with little outside resources, whereas the Western regions and Alaska are required of assistance to complete in that time. So for ecological site activities, obviously, I think you've heard this, we're powering through the provisional ecological sites, and we have till the end of this year to complete those. Alaska and the territories 2025. So at that point, we're going to be focusing on those developed provisional ecological sites to bring them to approve their correlated status. And there are a couple of ways that we can receive assistance in this effort. States can help regions focus on high value projects, for one thing. They've done that in the past. They've helped us focus on areas or other areas that are very important for programs. And they really, in the future, the states and our non-NRCS partners are really critical for that effort. If we have any hope to develop the detailed ESDs in the future. So regionally, we've got 2 MLRAs remaining for FY20. Actually, 124 has been completed already, and then 135B in southern Arkansas. We're also assisting Mark Twain National Forest with a comprehensive update and ecological site project that's been going on for the last 2 years, actually 2 to 3 years. And also, we're going to be developing a digital soil mapping project, or actually that is a DSM project itself. And then we're also going to need to add state transition models to other parts of the MLRAs that we've already completed, because those were not in the original instructions. And then all provisional ecological sites will be linked to components, map unit components. We didn't include those in the FY20 web soil survey refresh, because we wanted time to actually work through that process and really warn the states that this was coming down the line so that they can prepare for that. And then again, the takeaway is we need to engage the states for future prioritization work to develop those detailed ecological sites. And then we can have them assist us in focusing on those areas of greatest need. Dynamic soil properties projects, Chad had already gotten into that. Basically, those are properties that change with land use and management on a human time scale. And they're important for measuring and interpreting soil quality and soil health. So nationally, we're supporting in particular soil health projects with DSP elements to them. And then we're also engaging our teams and partners to identify projects of mutual interest, try to leverage resources. And the goal is to have all soil survey offices participate in DSP projects and data collection, and all offices are tasked with that. So regionally, we're expanding the dispersed and extensive data collection for our projects. Also, implementation of the intermediate tier projects. So some are going to be nested projects or DSP a DSP element within a larger MLRA project. Sometimes they're standalone projects as well, especially those that we are partnering with states and universities with. And then again, all offices are developing these projects. And currently we're helping develop the Soil Information Network to share data and research with our partners. And regionally, we've got the Coweta Hydrologic Laboratory in Western North Carolina. And there we're working with the Forest Service to develop one of these projects. And then MLRA projects, this is really the meat and potatoes of our region. The missional seamless coverage of soils information. It's been our goal, and it continues to be our goal. And regionally, we've got a landscape-based MLRA update projects is what we're trying to focus on, because we see a greater benefits from those types of projects with consistency and continuity. also the efficiency is there, as opposed to individual projects that are scattered around a given MLRA. And then also states can assist us with a conservation priority or land-based projects. Some states instituted a focused conservation approach. West Virginia, I know Oregon is another, and there may be some others. And working with those approaches, we can also focus our efforts on higher value areas for the states. And then also the tech and management teams are playing a larger role in prioritization of those projects, identifying projects. CART came along this last year. We've identified database tabular edits. We've already completed some, but there are also others that have been identified by the using the CART process and some of the reports to check for data integrity in order to meet. And then we're also increasing the use of digital soil mapping techniques. The Cahutta wilderness area is one of those presently, and we'll be looking at others in the future. And then also the move towards raster-based projects and the digital soil mapping efforts are pretty critical to that. And these are basically probability maps showing all components or soil properties. And we should be able to assist conservation planning more efficiently in the future using these. So just within Region 6, this is a snapshot of first named component. And you can see it's not exactly a continuous properties map here. You've got county properties and county boundaries and state boundaries that are fairly well visible on this image. So what we're trying to do is break down those linear features of political boundaries, and landscape-based approach to MLRA mapping or updating is really one of the ways we see as a more efficient way of doing that. So with the landscape-based soil survey update projects, we're based on multi-county MLRA-wide projects, updates the full gamut of properties, and it should result in a seamless survey between counties. And then the Soil Survey Office technical teams helps identify where those projects should occur. Management team approves those projects for the full extent. Projects can also be subdivided to meet annual goals. And then we also maintain technical and management teams at the Soil Survey Office level. So typical portfolio projects would be within this region, MLRA-based projects or landscape-based projects. Initial, only 4 offices really have those. And then state requests, basically projects that meet their needs more specifically. Ecological sites, developing ESDs, they're less common because of the completion of PES and the loss of staff. So we've got to do a job of focusing on where we need to fill staff in the future to enable us to pursue ES projects in the future. And dynamic soil properties, tabular edit projects, and eval projects. Eval basically takes the place of SDJR. Those are fewer in number, although we've a few of them during the COVID maximum telework environment. So on the horizon, we've got dynamic soil survey that we're focusing on in some areas, and we should be expanding that into others as we learn more about it on our basically our first project, COETA. So at present, the limitations are we're dealing with a static or polygon-based product, and resolution often isn't suitable for site-specific conservation planning. So in the future, DSS or dynamic soil survey attempts to bring those static properties together, soil properties or dynamic soil properties. The increased resolution should provide a more useful product for both conservation planning and a variety of end users. It's really a new way of displaying, integrating, querying, and analyzing the soils data that we have. And
hey, David,
I think that's about it.
David, this is Sam. We need to move on to give the other speakers their time.
All right.
And if there's any questions, they can email you.
Yep.
Thanks, Dave.
Thank you. Take care now.
Next up is Kevin Norwood for Regions 10 and 11 update. Are you there, Kevin?
Yes, I am here, but I am having some complications pulling up my PowerPoint. It all of a sudden crashed.
Okay.
And I cannot get it up. But if you guys want me to talk, I can talk my way through it. It's no problem, but I would rather you guys to see my screen.
Okay. Hey, Jen,
Yes, Sam.
is there some way to help Kevin with this presentation, or should you just go ahead?
Kevin, did your computer crash and you're having to restart, or just the PowerPoint?
When I got ready to put it into presentation mode, it just all of a sudden crashed and restarted PowerPoint.
So Sam, would you like to maybe flip-flop Kevin with Dan and let Kevin work on his PowerPoint and see if Dan would be ready to go?
Sure. Is Dan, if Dan's ready, are you there, Dan?
Yeah, I'm here and I'm ready. I can,
okay.
Give me 1 second and I can get my presentation up and running and ready.
Kevin, you can send us a private message in the chat if you need to reach out to us for additional help on getting that PowerPoint back up.
Thank you.
Okay, Dan, you might want to start out with telling what Ag Handbook 296 is, because I don't even know what Ag Handbook 296 is.
Yeah, give me 1 quick second here.
Okay.
All right, can you see my screen?
Not yet.
Dan, it came on for a second where we could see your PowerPoint, and now we don't see it.
There must be a little lag. How's that?
Still do not see it right now.
All right, let me try sharing again. I apologize.
No, you're fine. Make sure when you push the share. Now we do see your desktop. There you go. Now we see your PowerPoint.
All right, fantastic. Well, my name's Dan Wing. I'm a senior regional soil scientist with NRCS at the St. Paul office in Minnesota. And I'm going to go over a brief overview with proposed updates for Ag Handbook 296. I'm going to go over some history and discuss what's being updated and why, and explain, and then also these efforts really began back in 2017 with the really major activities ramping up in 2019. When we look at the land resource hierarchy, Ag Handbook is a publication of our broadest delineations of land resource regions in major land resource areas on a continental scale. Land resource regions, or LRRs, are the broadest patterns of similar soil, climate, water resources, and land use. The next down on the hierarchy is major land resource areas, or MLRAs. These use the same criteria: soil, climate, water resources, land use, along with elevation, topography, and biological resources, to further subdivide these geographic associated land resource regions at a reduced scale. MLRAs are also groupings of geographically associated land resource units that are recognized at a finer scale. Ag Handbook 296 had its beginnings back in the 1930s with this map published in 1938-39. They identified problem areas, primarily with respect to water and wind erosion. This hand-drop map of the continental United States is pretty impressive considering the technology at the time. The primary criteria for this map was the present degree of erosion, topography, climate, soil, and vegetation. There were 10 regions identified, along with 56 problem areas and 30 subdivisions. The next map was produced in 1944 and looked at food production during World War II. This time they identified basic land resource areas and concentrated on locating present cropland, grassland, woodland suitable for cultivation, and present cropland not suitable for cultivation. They identified 9 regions with 67 problem areas and 82 subdivisions. In 1950, the publication looked at problem areas. You can see how detailed this map is getting. There are still 9 regions, but the problem areas almost doubled, growing to about 155. In 1965 was the first publication of Ag Handbook 296. It shifted from problem areas to resource areas and identified land resource regions and major land resource area in MLRAs, major land resource areas, for the continental United States. Although Alaska and Hawaii were newly formed states, they were left out of this publication. There's 5 criteria used to delineate the MLRA resource concerns. These are land use, topography, climate, water resources, and soils. There were 20 land resource regions identified, and MLRA is stated about the same at 156. The second edition was published in 1981, and this time it included Alaska and Hawaii. Vegetation was added to the criteria, and there were 26 land resource regions and 204 MLRAs recognized. Most of the increase is primarily due to the addition of Alaska and Hawaii. In the 1990s, there was a massive digitizing effort. Ag Handbook was published as a digital product in 1997. The land resource regions expanded to 28 and the MLRAs to 193. The 1997 publication also added geology to the criteria. So now we have 7 criteria that we use to distinguish MLRAs, and that's the same criteria we use today. In 2006 was the last publication, and it utilizes Sergo polygons to develop MLRA boundaries. Although it may have been a good idea at the time, it created some cartographic issues with maps, and the detailed boundaries of the MLRAs gave the impression that changes were abrupt and less of a transition from one MLRA to the next. With this last update, the land resource regions stayed the same at 28, and the MLRAs increased to 278. So why are we updating the handbook? Well, we have new and improved information available. It's been 15 years since the last update. We're also mandated to maintain the handbook in order to meet our customers' needs. We have improved climate and land use information. We have better modeling techniques, and we're supporting ecological site description and placing more emphasis on dynamic soil properties and soil health. Oops, excuse me. So what updates have we made? Some spatial changes include refined MLRA boundaries. We've corrected cartographic issues and developed an appropriate map for the 1 to 7.5 million acre scale. We've smoothed boundary lines for MLRAs. We've merged delineations that were too small for the scale, such as tiny islands or small corridors. We've made additions and recognized new subdivisions of MLRAs. And we've developed methodologies for editing, and we've captured these methodologies within the metadata. We've incorporated revisions that were requested by local, state, and national technical staff. This clip is an example of the current publication. It's zoomed in at a scale of 1 to 3 million. Here you can see the enormous amount of detail. And along the county boundaries. There are also several islands in the center. You can see there's a lot of little tiny islands. There's several small corridors that are used to link polygons together. If you look in the center of Minnesota, there's MLRA 91A. There's a lot of really small polygons, and there's a lot of really tiny small corridors that are used to to link those together. At this scale, you can see them, but at 1 to 7.5 million, it's really chaotic and doesn't meet current cartographic standards. So the next slide is the proposed spatial edits. You can see that the boundaries have been smoothed and simplified, and many of those small islands and chaotic delineations have been combined or simplified. Here we have both the 2006 publication and black lines overlaid by the new proposed spatial changes represented by color. You can see that most of the MLRAs are close to the original concept. There is the example of a combination right in the center. You can see that MLRA 91. You can't see it very well with this slide. It's not labeled, but a lot of the black lines in the center of Minnesota have been simplified. And the MLRA 91 and 91A and 91B have been combined together. And a lot of the small, tiny islands of outwash were actually combined with the adjacent till MLRAs. In addition to combinations, there's some additions. Up in the upper right, MLRA 56 was split out. This is the Red River Valley. 56A and 56B. 56B would be a forested part of this MLRA, where traditionally most of it was identified as prairie. At the very west, there's an additional 55D map unit, or excuse me, MLRA. This is a large lake plain that was able to be split out from the adjacent till plain. And then just next to that, 102D was newly created, and that is a climate break. What other changes did we make? We made to the narratives. We're updating the definitions of each MLRA. We're utilizing PRISM and NEDS data to produce statistically valid tables for precipitation, temperature, and elevation. We're adding descriptions of transitions from one MLA to another. Are they abrupt, diffuse, or irregular boundaries? We're adding maps and images to help convey area concepts. We're adding additional landform, soil profile, and vegetation and land use pictures. And we're also developing broad-scale soil property maps. The final product is scheduled to be completed in the fall of 2020. It'll have 28 land resource regions, 270 MLRAs. It'll be available in PDF format and paper-bound copies. It'll include the entire United States along with the Caribbean and Pacific Basin. The lower 48 in Alaska will be at a scale of 1 to 7.5 million scale. Hawaii and the rest of the protectorates will be at a scale of 1 to 1 million. For more information, you can go to the NRCS Soils webpage under Geography, and you'll find any posted information there. I'd like to recognize Dr. Monger and Chad Ferguson as the two leads in Lincoln that have really moved this project forward, along with the MLRA soil survey offices, MLRA technical teams, state soil scientists, and NCSS cooperators for all their input. And they've really gathered the information and put together the changes that you're going to see. And of course, the soil survey regional offices have really been instrumental in bringing all the information together. Thank you very much.
Okay, thanks, Dan. Is Kevin ready, Jen?
Yes, sir, I am ready.
Okay, great. It's all yours, Kevin.
All right, thank you, Sam. I appreciate it, okay? Can you guys see my screen?
Yep, I can see it, Kevin.
Okay, all right, thank you. First of all, guys, I would like to apologize for that little hiccup. Technology sometimes will catch you like that. Actually, I felt like a musician that was on the stage, had my equipment ready, and the band was beginning to play, and I was playing with the band, but nothing was coming out of my amplifier. That has happened to me before. However, I am here to talk about the North Central Cooperative Soil Survey Workshop as far as my region, regions 10 and 11. All right, so I'm just gonna go ahead and jump in. Earlier, Dr. Dave Limbo talked about the cooperation with the soil scientists, SPSD, all of our states, and also the universities, and also private consultants as well. Guys, I want you to take a look at this. This is a testament of our cooperation. If you look at this, this is Technical Soil Services. This is kudos not only to SPSD, but also to the states and also to our universities and also to our partners as well. This is a testament of our cooperation. Good job, everyone. When I first saw this, this was so impressive to me, and I hope that when you see this, this is impressive to you as well. All right, so Region 6 and both Region 5, they talked about, well, I know Region 6 talked about initial soil surveys, but also in Regions 10 and 11, we are still focusing on initial soil surveys as well. We still have two. We have Pine County that we have been working on. We have plans to get that finished by 2026. But in the past, we did not have an office leader. Now, I am happy to say we do. We have Mike Rokas. He is now the office leader that is in the Duluth office. That will be covering this area. But before Mike took over as office leader, we had Betsy Shug, and she actually came in and she worked on Pine County, and she actually did a lot of DSM mapping that really took care of some parts of Pine County that really helped us move forward. Really happy about that. So another good example of digital soil mapping, we also have Superior National Forest, Chippewa National Forest, and we have others as well. So as far as those go, we also have just completed a new service interagency agreement with Superior National Forest and Chippewa to not only complete the initial soil survey work, but also to update and harmonize existing soil forests with more detailed information surrounding the areas through traditional and digital soil survey update projects. We're also looking to continue this arrangement in collaboration well into the future. So we're still moving forward with that, with agreements as well. All right, so I know Chad and Dave Kingsbury, they talked about raster soil survey and digital soil mapping. Region 10 and Region 11 have been working on this for a little while now. And I'm really happy to say we have some individuals that's really taken the lead and really pushed this forward, and it's really helped. So as of right now, for 2020, we have a total of 2 million acres. As far as products that are available, we have 4.5 million acres. And for 2021, we have 3.2 million acres of raster soil survey products that we're trying to accomplish. As far as MLRA MLRA field projects, we're also moving forward with those as well. We're using DSM to really correct a lot of the information that's out there. You see some examples that are out there as well. You see you have Surgo that's 1 to 24,000. Once that project is completed, you see it as at a 10-meter resolution. So as you talk about digital soil mapping, you're talking about a more detailed and refined product. And as you can see, the examples from right to left are the scales that are available. You can see your general soils map at 1 to 250. You see Surgo at 1 to 24,000. Once you get to a raster soil survey, you're looking at 10-meter resolutions. So as far as DSPs go, we have been pushing forward with that in our region, and we have a good example right here. The MLRA 104 that is out of the Waverly, Iowa office, they're doing a long-term DSP study that's looking at conventional till versus conservation tillage. Some good examples. You look at the top, which is conventional till. After a 5-inch rain event, you see you still have water, and you see conservation tillage down at the bottom with cover crop after a 5-inch rain, and you see nothing. So what they're trying to do is accomplish that worked with the field offices and also worked with the states. And as a result of this project, they hope to better understand the effects of different management systems on soil and ecological sites. This project includes benchmark soils that includes Dinsdale, Kenyon, Marquise, and also Ostrander. And so they're working with the field offices and with the states on this project, which is very good. So another project that we've also completed is the update of the alluvial map units in the St. Louis metropolitan region. This was work from the Union office with Ralph Tucker. So this project actually started from a lot of requests from, I think, from the city and also the Missouri Department of Conservation, because they wanted to recognize areas that that flood. And so we began to work on that. We developed that and made it into an MLRA project and moved forward. And some of the ways we were able to define and also identify some of those areas were through LiDAR. And so we used that to actually identify a lot of those areas and to create a better product that will be able to help the city and also the Department of Conservation as well. We also have a project that we just completed in Marion, Illinois, bench landform MLRA projects. We've been looking at that and we've worked on that for this year. Okay, so during the modern soil survey bench landform phases of the Blueford, Cincinnati, Holton, and Wynoo series considered to be upland soils were mapped in Franklin, Jefferson, and Williams counties. The occurrence of soil on bench landforms were noted, but were not mapped during older soil surveys. This project was distinguished and mapped glacial bench landforms consistently across MLRA 113, allowing for a better understanding of glacial geomorphic landscape, as well as soil properties and soil interpretations on bench landform. This is a good example of what was created by John Bathgate to actually help this office to identify a lot of those. And they use those to identify by the 8-digit watershed in the region. Good job from the Marion office. Okay, so want to talk about a little bit about provisional ecological sites. In Region 10 and 11, we've had a lot of turnover. We lost our regional QA, who was Stacy Clark. We lost her to the Forest Service. We also lost Lisa Klusner. She also went to the Forest Service. And we lost Tyler Staggs. He went with the state of Indiana on the conservation side. So that pretty much left the cupboard empty. But we still have soil scientists that were working on it. And we also, we're really appreciative for Region 5 for allowing us to use Chris Tecklenburg to come in and help assist the offices and also get a lot of MLRAs completed. And we also have Anita Aarons that we inherited from Region 6, who is now in our region. She's also working really, really well with the offices to get a lot of these completed. So we're still thankful, but we still have a whole lot more work to do. And this is just an example of some of the MLRAs that we've completed. So this is our staff for the Great Lakes Midwest region. This is the St. Paul office. This is all the staff. And then you have the staff out of Indianapolis. Any questions? So before I close, if there are no questions, I would like to throw this information out there. In the fall, we will have a hiring of recent grads throughout our division. And I would like to throw this out to all university partners that once we get this vacancy out on the streets, we're asking that if any of the university partners have any students that are looking for jobs, we're looking for recent grads. So if you have students that are just graduated or have graduated in the last couple of years, we will be able to take them because we're looking at hiring soil scientists and ecologists throughout the nation. So I would like to put that plug out there as well.
Hey, Kevin, for the jobs, the turnaround is pretty quick, right? So they should be on USA Jobs already, ready to apply?
No, the vacancy is not out on the street yet. Once we get it out on the street, we will let all of the universities know. I just want to just put that out there as just something to be looking out for in the future.
Okay.
Other than that, that's it, Sam.
Okay, thanks, Kevin.
Thank you.
Okay, let's see. Mark Stolt, are you there?
I'm here.
About 8 to 10 minutes, Mark. Fill us in on ICOM SAS, and then be nice to leave a little bit of a break before the featured speakers start. So it's all yours.
Okay. Hopefully everybody can see my screen.
Yes, we can see the screen.
All right, great. So thanks for a couple minutes. I'm talking to all the regional National Cooperative Soil Survey conference here about this wet soil order and soil taxonomy. These are the efforts of the International Committee on Subaqueous Soils. Many of you may be aware that there's a lot of efforts that's gone on over the past 5 or 6 years to make fundamental changes to soil taxonomy. These are being driven by just the increase in taxa that have been added to soil taxonomy over the years. Taxa have been added, but sort of the bigger picture of the classification system hasn't really been reviewed. Just for an example, this is the number of subgroups that have added between 1975 and 2010 in the Inceptisol orders. And you can see it goes up from about 150 to over 300. So essentially doubling in that amount of time. So the system really isn't a basic system any longer. To sort of take a stab at trying to fix this, a group from the National Cooperative Soil Survey developed this illustrated guide to soil taxonomy. It was initially called the Simplified Guide, but no one wanted to give the idea that this was actually simplifying or dumbing down soil taxonomy. And the idea of the fundamental changes is far from that. So it's really not anything to do with simplifying it or dumbing it down. It's just reorganizing it to make it a better system. And there's a couple problems with the illustrated guide. It's an excellent college source for soil taxonomy, but it only classifies to the grade group level. And so we're teaching our students how to classify soils to the grade group level. However, in the grade group level, there are many what we call garbage can taxa. Here, they're distrodepts, maybe where you guys are, they're haplostaups, that really are not very helpful when we're trying to interpret soil surveys or make use and management decisions. And then only about 90% of the classifications in the illustrated guide are correct. In 2015, the task force to develop fundamental changes in soil taxonomy was formed within the Soil Science Society of America. The primary objectives were to develop a system that is more efficient and useful for the soil science community that it serves, and also to serve as an effective, engaging tool for the soil science community to reach out to other disciplines and communities that use soils information. These are some of the issues that the task force has addressed. There are proposals in review right now for redefining the molic epipedon and organic soil materials. There's a paper in review right now about moving the soil moisture regime to the family level and the pros and cons of that. Though it's not a charge of the task force, the idea of creating a soil order for anthropogenic soils was probably a consequence of these efforts. And then I'm going to talk about the wet soil order for mineral soils today real quick. David Lindbo and Marty Ravenhorst were essentially charged with developing the initial sort of proposal for this wet soil order. They developed this poster that was essentially displayed at conferences around the country and at regional soil survey offices and also at international. The question was, should we have a wet soil order? And then where along that continuum should we make the break for that wet soil order? There was actually an unofficial poll that was conducted at the 2016 Soil Science Society of America meetings. And about 40 people participated, and about 95% indicated that they thought there should be a wet soil order. About 45% said the break should be at the per-aquic soils or wetter. But you also should recognize that almost just as of people thought that it should be on some of the drier soils. So in the following years, we brought this idea of the wet soil order to conferences, national conferences like the Soil Science Society of America, National Cooperative Soil Survey meetings, or the field tours that essentially were associated with these meetings, and talked to different folks about it and got ideas and so forth. Last year, the International Committee on Subaqueous and Aquatic Soils, or ICOMSAS, was formed. Marty Ravenhorst, many of you may know Marty. He's probably the best known or most well-known wetland soil scientist in the US and maybe in the world. Everybody knows David. Joe Parsley was a soil taxonomy focus group chair. Jim Thompson worked on wet mollisols, hydric mollisols, for his PhD dissertation. Matt Ricker, a new faculty member at North Carolina State, over the last decade or even more has been working on riparian soils and alluvial soils. Peter Shad and Corny Van Hoysten, these are the first and second authors on the WRB, or the World Reference Base of Soil Classification. So that's the other international classification system. Rob Fitzpatrick is one of the primary authors on the Australian classification system. So these are the folks that made up the committee. Last year we met about this time for a week-long meeting. Prior to the meetings, we had conference calls and many emails back and forth to develop the initial components of the wet soil order taxa. At the meeting, we were at had field trips and so forth to look at various wet soil orders and relative to the proposal. Also later on in the year, in November, we had a day-long meeting to sort of hash out some more of the proposal. And then over the following months, we developed the proposal. The proposal is available for review on this USDA NRCS webpage. If you see there, it says NRCS, National Cooperative Soil Survey Regional Standards and Taxonomy Committee Proposals. So you can access the proposal right there. It has a good introduction that you can sort of read about a little bit of the history and why we think that we should have a wet soil order. Under the proposal, if we have the anthropogenic soils, they would classify first, then the gelisols, then the histosols, and then finally the wet soils, which we call aquasols, that have the formative element AQ. The wet soil order is one where the water table comes close enough to the soil surface and stays there long enough to alter the soil morphology and impact the use and management of those soils. In this proposal, we're defining those conditions as having essentially aquatic conditions within 30 centimeters of the soil surface. Now, these are the suborders. The Wasatchs are the subaqueous, Purax, ones that have a puraquic moisture regime, Leptax that have a root restrictive feature, Verdax that have verdic soil properties, Humax, soils that have, wet soils that have a lot of organic carbon, such as a histic, malic, melanic, or umbric epipedon. The Somax are the sandy ones, Arjax have an argillic horizon, and then the Orthax. There are taxa at the great group level and at the subgroup level in the proposal for all of these suborders. These are just our examples of Sulfipurac subgroups. So Sulfipurax would be the great group, and then you can see the different subgroups that are here. Right next to their definition in parenthesis in bold are some soil series that represent these taxa. So when you get a chance, look at the proposal and see where the wet soil order series that you work with are fit within the proposal. What will we like from you, especially any comments on the proposal? So please look at the proposal, and any comments that you have, please send them on. Specifically, we want to know if there's any soils that we've left out of the classification that you can recognize. So if you could send us those proposals and say, hey, what about this soil or what about that soil? You can send those comments to me. There's my email address, or you can send them to your soil taxonomy chair, either Matt or John, and they will forward those to me. Thank you very much for your time this morning. And again, please send me any comments that you have about the proposal.
Okay, thanks, Mark.
You're welcome.
And I'm sure you'd like to see emails from you if you have any questions or concerns. So
Sure enough.
Hey, Jen. How about Martha?
Sorry, Sam. Somebody had a quick question on if he would be accepting, how long they would be accepting and reviewing comments on the proposal.
Did you hear that, Mark?
We'll continue to work on it. So any comments that you send, please don't feel like you got to send them tomorrow. But we'll continue to work on the proposal probably over the next, I would guess, maybe on the order of 6 months or something like that.
Okay, thanks, Mark.
Oh, you're welcome.
For the next one, Jen?
I believe Martha is ready.
Okie doke. Next speaker is one of the featured speakers, and it's Dr. Martha Shulsky. She's from the University of Nebraska-Lincoln, and she's also the state climatologist for the state of Nebraska. And she's going to talk about climate change, planning in cities, lessons learned from partnerships on the plains. It's all yours, Martha.
Great. I'm going to share my screen. If that looks all right, I'll go to preview there. All right. And my voice sounds all right? You can hear me okay?
You sound perfect, and we can see your screen.
Okay, very good. Thank you, everyone. I really appreciate the opportunity to speak with you today. You might be wondering, why would I be talking about climate change in cities at a soils conference? And what it's really about is localizing climate information. So I hope that you'll find this relevant to the work that you do. And just a little bit of background. So I actually got my PhD in soil science at the University of Minnesota, and Dr. Tupas mentioned Norm Borlaug, and that's where I was housed in, was Borlaug Hall there at the university. But I'm a meteorologist and climatologist by training. I just happened to go through a soils program, so I do have an appreciation for soils and their importance in solving climate change. So I'm going to be talking about a NOAA-funded project that I was a part of, localizing climate information for cities, where we worked with about a dozen cities in a 4-state region, including Missouri. And we had a number of different partners. I worked with the Regional Climate Center, as well as the Public Policy Center and the City of Lincoln, and then a whole range of other cities throughout the region. So just to begin, just talk about some realities of climate change. It's here and it impacts all of us. It's something that the National Climate Assessment talks about in the most recent kind of assessment of climate change and realities here. We are the cause, but we're also the solution. And the sooner we act, the less risky it is. So those are kind of some of the messages that I talk about when speaking to different audiences. One thing that I think is really important to keep in mind is that the Yale polling, which polls the citizens of this country about every year, look at how the perceptions of climate change and how people feel about it. And most Americans do feel that climate change is happening. However, there's a disconnect in terms of personal harm. So most Americans do not feel that they will be harmed personally from climate change. And this is where I think meaningful and relevant dialogue is key. And sometimes this can be a really controversial subject to talk about. And so talking about soil health or farm profitability or conservation, those can be really good talking points to engage people and try and pass legislation that targets climate change, but perhaps it doesn't say it. It comes at it another angle. In fact, the state of Nebraska, they passed a Healthy Soils Task Force, which does kind of target climate change. All right, the image that you see here on the right, that is kind of a teaser for some of the tools that I'm going to be showing, which looks at if you're in Columbia, what's the change in the average summer high temperature? By the middle of the century, it'll feel more like you are in northern Arkansas than the northern part of Missouri. Okay. So looking at cities in particular, we know that cities are facing increasing challenges due to the impacts of climate change. And this is largely played out in health impacts, water management, whether it's too much or too little, infrastructure and the impacts that say lack of precipitation too much has on infrastructure, as well as energy demand. So those are kind of the key components that impact cities. And just another image here from the National Climate Assessment in looking at changes in summertime conditions. We'll look at the higher emissions scenario, so that assumes business as usual approach. Middle of the 21st century in Columbia, we're looking at the number of days we go above 90 degrees to basically double. So now the average is about 35. So we're looking at going up to 65 by the middle of the century. So climate change is certainly impacting cities. Also, a lot of cities are leading the efforts in response to climate change, both in terms of adaptation as well as mitigation. We have not been proactive at the federal level. And so a lot of cities are taking this on in terms of how do we adapt in a changing climate? How do we manage stormwater runoff? How do we improve health? Let's look at building codes, all these aspects that help to deal with the implications of climate change. And cities, some cities are really leading in that effort. Okay, so that leads to this project, and it has occurred over the span of about 7 years or so. So initially, how it got started is city planners in the following 5 cities that you see listed there. So Columbia, Missouri was one of them. They are part of this Urban Sustainability Directors Network, which is a peer-to-peer learning group among cities that are a part of this sustainability network. So each of these 5 cities were a part of that and reached out to climatologists and said, we are looking for localized information. We want to include climate change projections into our planning efforts and look at what the conditions will be like into the future, look at ways to adapt and look at mitigation measures. And what we learned from this engagement with these cities is that they are seeking customized and local climate information. There's, as you're probably aware, there's a plethora of climate change information available, but translating that into something that is useful and usable is extremely important. That's where a significant gap lies in what we found. And the cities are facing challenges due to resource availability. They don't have the staffing or the expertise or the funding to look into this in detail. And so that's where us as climatologists come in. So, so how do you start engagement with cities, and what kinds of things do you talk about? How do you make climate information relevant to them? And so this is a busy table, I realize, but this is what is found in the report that you saw, the cover of that report on the previous slide. And so what we did is start on the right-hand side of this chart, looking at the municipal concern and what do the cities care about. I'll just point your attention to the heavy rainfall category here. They're interested in planning for stormwater management, floodplain, emergency response, and infrastructure design. So that was their primary concern. And so we backed up and said, okay, given that's your concern, what are the metrics that we need to look at to help with these planning efforts? So we looked at heavy precipitation events, the wettest 5-day period, the wettest 15-day period, different ways that you can classify and categorize heavy rainfall. How are those changing over time, and how will those change in the future? And as you can see, there are other metrics. Public health is one of them, snow events, freeze-thaw cycles, last frost in the spring, first frost in the fall. All those things were identified as municipal concerns. So again, we looked at the climate metrics that specifically spoke to these types of concerns. Okay, so that was kind of an initial project, and then we got some more funding to continue on with this program and broaden out to a wider range of cities. And so what we wanted to do was assess their local planning efforts, create some tools that would be helpful for them, and then evaluate how effective those tools would be. So I'm going to share kind of some of the key points from what we found with this this effort. So we had some listening sessions and workshops where we brought representatives from the different cities together. And here are just some comments that we heard around the region. So how the impacts are manifested, that varies across the region. In targeting the central US, there's a lot of variability from western Nebraska, western Kansas into Missouri and Iowa. They have different climates and they have different concerns, and the impacts of climate change are manifested differently. A common theme that we also heard, which I hear really at any workshop that I go to, is an increase in efficiency and interagency collaboration and kind of breaking down silos and allowing information to move more freely to produce better tools to help to be helpful. And then finally, the influence of climate change on the economy. So this, in the lower left-hand part of the slide, this particular comment was made, I believe, from somebody in Western Kansas, saying that they've had to turn away businesses, the city council has, because the water demand that they would be putting on the system, there's just not enough water to support growth in the cities. Okay, so we'll look at what are these communities dealing with, and what are they saying? So we sent about 300 surveys. About a third of those were returned and targeted smaller communities. So that's the 5,000 to 10,000 range, micropolitans, 10 to 50,000, and then metropolitans would be larger than 50,000. So these were the different sizes of cities that we targeted. And so we asked them on their use of climate information and perceived barriers to that use, looking at climate-related policies that they have in place, and then finally attitudes toward climate change in their local area. So this survey was sent to a city or town manager, administrator, chief of staff, or mayor. It depended on the size of the city. This survey was administered by the Public Policy Center at Nebraska. And so some of the key findings here, we did find that 60% of the municipalities surveyed currently use little to no climate information for planning. So a majority of the cities in this 4-state region do not incorporate climate information, climate projections into their planning efforts. Why did they not? So we did identify specific reasons that they could choose from, or they could enter their own reason. It was open-ended question as well. So the top reasons for not incorporating this information is lack of awareness about the value of using such information, as well as lack of best known practices to integrate climate data into planning. The positive thing to those barriers are we can work on those. We can increase awareness. We can share best practices for incorporating climate information into planning. How do they want this information delivered to them? Localized information specific to cities could increase the use of climate data into planning. Okay. So looking at differences among the size of the cities, so the level of concern about climate change was consistently higher among metropolitans, so that's greater than 50,000, when compared to micro, which is 10 to 50,000. So that showed a statistically significant difference in a level of concern about climate change. And perhaps what I think is one of the most important outcomes of this survey is the most effective ways to frame climate-related planning for support or understanding is two key themes that bubble to the top. One is disaster, extreme weather preparedness, and secondly is a cost-benefit analysis. So think about the weather side of things. That's how climate change manifests, is through extreme weather events, as well as the economics of better planning. Okay. Another aspect of the project was looking at local comprehensive plans, hazard mitigation plans, and these could be multi-jurisdictional. So it could be a city that partners with a natural resource district to create a hazard mitigation plan, as well as local emergency operating plans. So what we found with assessing these local planning documents across the 4 states was that there's a lack of broad and systematic implementation of climate information into planning efforts. So this kind of goes along with the surveys that we sent out, in that there's a general lack of inclusion of this climate information into the planning efforts. Okay. So what we came up with, so in working with the cities, we identified the best ways in how this information they would like to have it presented. So we came up with this interactive web tool. The address is given there. So I'll take you on kind of a tour of this. And one of the things that we came up with is city reports. People are looking for localized information. And so for each of these cities, we designed, in working with them, we designed a localized report, which here's the front cover, as you see here. All these reports are available and freely available for download. But looking at temperature and precipitation trends at a regional, statewide, and local level. So it puts the local trends into perspective of what's going on statewide and what's going on regionally as well. Looks at local extremes. Often it's those extreme events that are kind of the high impact events. So heavy precipitation events, high daytime temperatures, high nighttime temperatures, drought events, those kinds of extremes. Also looking at future climate projections. So the products that are available from the National Climate Assessment, the different climate scenarios that are available. And we primarily focused on 2 main scenarios. The business as usual approach, which assumes no action on climate change and no mitigation efforts. And then a lower emissions scenario, which does assume some active climate mitigation. And then looked at what are the implications in these different cities. And what was interesting is even if you are in Dubuque, Iowa versus Hayes, Kansas, generally it's water resources, energy, and public health are the primary ways in which cities are concerned about the implications of climate change, and again, the way that climate change will be manifested in the local areas. So again, all these reports are available for download. So that's just the local level, but one thing that we wanted to do was to scale up, look at a broader scale, so that if you are in Montana and interested in the same information, that you would be able to gather this localized climate information and climate projections. And I just wanted to mention this this top quote here. These are comments that we heard from the cities. So I appreciate the data, if nothing else, just to be able to have a frame of reference when they, meaning city council members, make those tough decisions. And what struck me in talking with the cities is sometimes you might only have 5 minutes to make your case for why you should look at this type of planning. And so this needs to be very simplified, very easy to distill this information. We've got such a short time period on an agenda for a city council meeting. So decisions can be made pretty quickly. So this information needs to be very accessible. Okay, so I'll explore some of the tools that we have available. And again, while it does, the title does state municipal climate adaptation, it's really relevant for more than just cities. All we're doing is localizing climate information and localizing those climate projections. And for a specific area, what has your trends been and what do we project the trends will be in the future? And giving some context for these trends. So the URL, if you want to search on your own, the URL is listed below there, and I'll highlight some of the tools here. So what you're seeing here is an example from Kansas. If you want to look at spring average temperature, whatever seasonal metric you're interested in, it could be average high temperature, low temperature, precipitation during summer, annual precipitation. Those are the kinds of metrics that you can search, and you can look at the period of record that you would like. And it seems pretty simplistic, but this graphic will give you what is the rate of change. So it's a nice simple way to look at the historical trends in your area. If you want to compare certain areas, then you can pick one location, compare it to another, and look at a time series plot of that. Okay. One thing that also might be important is looking at what the average conditions are currently as compared to what they will be middle of the century. So what kinds of changes are we expecting in a business as usual scenario? The example that you're looking at here happens to be for Kearney, Nebraska, and you can see, things are shifting upward. Those temperatures will be expected to increase. By middle of the century, there's about a 4 to 5 degree warming with business as usual. If we go to the end of the century, that rate continues. It continues to increase. It's about 9 degrees warmer on average. If we put climate change mitigation measures into place, then that will hopefully level off. But you can look at what your climate future will be with this tool. Okay. One of the things that we heard from the cities is being able to go a little bit beyond just the numbers of a degree Fahrenheit warming, but to put it into context of what, if I'm trying to convince a city council member on this, a way perhaps to look at it is this idea of a sister city. So a current average temperature for South Central Nebraska will be, you're shifting, things are warming and your climate is shifting so that it's going to be like you're further south, actually. So the ability to find this sister city was something that the cities had said they wanted. And so that tool is also available here. And you can pick your emissions scenario, and really see kind of decisions that we make now. How will it play out in our climate future? So the image on the left is a lower emissions, which is RCP 4.5. That just means representative concentration pathways. And again, that's putting climate mitigation measures into place. And then the higher emissions, this RCP 8.5. That's, again, the business as usual. So you can see how much more warming and the difference in that sister city. Okay. And then one more feature that we have available is one of the things that the cities told us that they would like is an easy way to search other city plans. And told us that they learn a lot from what other local areas have done and try and incorporate those best management practices and those lessons learned into their own planning. So there's a nice kind of clean, searchable way that you can look through city plans that are actually across the US. It's not just the 4 states that we focused on, but it's across the US. So you can search planning documents, municipal planning documents, and see how they've tried to incorporate green space or recycling or you know, whatever aspect of plans that you're looking for. There's a nice, easy, straightforward way in which to do that. Okay. So we are evaluating this tool. We did, and it was just released last year. So we're continuing on with this evaluation process, but some of the early things that we're hearing is this word cloud shows you the kind of the key phrases that have appeared from surveying the effectiveness of this tool. And so planning certainly stands out. Again, a thing that the cities are finding initially is that having this science-based, local and relevant information is very helpful for them to even just start conversations. Where there was previously no conversations, it's a good tool that is very locally specific that can be useful to start having conversations. So those are kind of initially what people are telling us and what they've found this to be useful. So it will be interesting to see over time kind of how more specifics into how this evaluates and how effective it is. So just some things that ways in which we have utilized this tool. It's generally continued with the theme of communities. We did host an event last year in Kearney. It was a public forum, and we invited the mayor of Greensburg, Kansas, to give kind of a keynote talk, and just a good way to continue this conversation and learn from other communities that are building more sustainably and looking actively at mitigation efforts. The tool is also utilized in municipal water planning. So for the city of Lincoln, they are looking at water availability middle of the century. And so this information was included in their report. And the interesting thing that we have found was for where the city of Lincoln gets our water. It's at a place actually that's between Lincoln and Omaha, so it's not local. It's about 30 miles away. And because the state of Nebraska, because we have gotten wetter over time, we've increased precipitation by about 10%. That trend is also expected to continue. So the historical trend will continue into the future. Because of that, the city of Lincoln actually does not need to go to a different water source. So by incorporating this climate change into these groundwater models, we found that the current system will suffice for the city of Lincoln. So just one application of this tool. And we were in the planning stages of workshops for flooded Nebraska communities from the March 2019 flood. Nebraska was hit pretty hard last year, and looking at hazard mitigation planning, again at the city level. Unfortunately, those workshops were put on hold because of the state of the world right now, but we hope to start those up again at some point in the future. I'll also had folks from the agricultural community here in Nebraska reach out for doing similar of these local climate reports for the agricultural community. Rainfall in particular is something that is a key issue. The variability in rainfall and the enhancement of extreme precipitation events and the impact on soil erosion and agricultural production is a big issue, especially for central and eastern Nebraska. So that's some interest that I've had from the agricultural community on this project. And so it looks like I've got maybe about a couple minutes left. I would be happy to take any questions that you have, and I hope you found this interesting. So thank you very much.
Okay, thank you, Martha. If there's any questions, I think you email them to Jen, and then they send them to me, and then I get them to Martha. But I'm sure if you send her an email directly, glad to answer any questions you have. Are you there, Jen?
I am. Sam, I did just forward you a question.
Okay. Let's see how good email is here. The electrons are running slow today, Jen. It was to the SIU address, Jen, is that?
Yes.
Okay. Well, do you have it? Can you go ahead and ask it?
Sure, I can do that. Our personal beliefs, both in
That would be better.
Our personal beliefs, both in science and in climate change, still a challenge to overcome in addressing the societal issues. What is the best motivation for changing behavior to adapt to climate change, which is a long-term effort, but with short-term needs?
Yes, great question.
There is also a reference, I'm sorry, Martha. In a recent news article, for the first time, the alarmed are now the largest of global warming's 6 Americas. How can we take advantage of this shift?
Yes. So in my role, I serve as state climatologist, and so I'm asked to talk to a variety of groups, mostly around Nebraska, and encounter a whole range of perspectives on this topic. What I have found that works the best, well, first of all, I'm finding that in general, kind of the needle is shifting. And so what you found with that alarmed category, I'm finding that to be the case in Nebraska as well. So I am starting to see a shift in attitudes, but I still run into those people who don't believe what I'm telling them. And so the strategies that I utilize is listening to their thoughts. I largely work with those in the agricultural community. And so I will listen to what their perspective is. I find that often they want to be part of the solution and they feel like they're being blamed for the problem. And I find that if you switch it around so that you bring them in and offer them as part of the solution rather than the source of the problem and finger pointing, that is helpful. I also find that what they're describing, when I listen to them, what they're describing is climate change. So they see it and they know that it's happening and they experience it. And things like the flood of 2019 are a great learning tool and gateway to talk about climate change. So we talk about weather events. There are climate deniers, but there are not weather deniers. So you connect those dots to extreme weather events. That's one strategy. And finally, if those fail, then you come at it from another angle. And as I mentioned in the beginning, healthy soils is a great, another great gateway to tackle climate change. And because nobody wants erosion on their fields, people want to conserve resources and spend less money and increase their profitability and save their farm for generations to come. And so framing climate change, talking about it in a different way, and perhaps not even using climate change, but talk about healthy soils and risk management and weather-ready farms. That's another project that I finished looking at risk management to extreme weather events. So those are some things that I have found that at least opens the door to communicate with people on this topic. Because if you close the door from the beginning, then you're not going to get anywhere.
Okay, if there's any further questions, go ahead and email Martha directly. Thank you, Martha, for your time.
Thank you very much. I appreciate the opportunity.
Okay. You there, Mike?
I'm here, Sam. Can
okay.
You hear me? I guess you can.
Yeah, and you're the last one before lunch, so you don't have to drag it out too far.
All right.
Okay, next up is Mike Wilson, National Leader for Climate Change, and he's going to talk about assisting agricultural producers in adapting to climate variability and change. It's all yours, Mike.
All right, thanks. I appreciate this opportunity to speak at this conference as a longtime soil scientist with NRCS. But over the last 7 years in my current position, I'm a senior scientist, and my job is to work with national headquarters or through national headquarters with people from different agencies and universities and other organizations on issues related to climate change and adaptation for agriculture. And I have 3 other co-authors listed for this presentation: Kristen Giestein, who's a conservation technician in Indiana; Elizabeth Marks is a biologist in New York; and Dan Kesey is a wetland conservationist in Texas. And all 3 of these folks are NRCS employees and working on details with the USDA Climate Hub this year. And I'll talk a little bit more about that. Now, in this presentation, I'm going to illustrate some of the activities that USDA has had on climate change and variability over the past few years, and talk about where we are today and what sort of activities are taking place. Also, there's multiple resources and tools produced to assist farmers, ranchers, and foresters through the efforts of the climate hubs. And NRCS staff has really been involved in quite a few of those as well. Well, anyway, first, just a brief history of some of the actions at the USDA level that have taken place over the last several years. And I want to span basically 2 different administrations. The first one was in 2013. The President's Climate Action Plan ordered USDA to create these regional climate hubs. And so these hubs were formed to assist producers in adapting and building resilience to weather events and a changing climate, also to address greenhouse gases, thereby reducing the impact of agriculture on its impact on climate change. A couple years later, there was developed under the leadership of the USDA Office of the Chief Economist. We started having all the USDA agencies working together on tracking and trying to increase various aspects of conservation that impact agricultural emissions. And you can see that these building blocks address several key areas, including soil health, nitrogen, CRP type landscapes, grazing lands, and forests. And many of these building blocks were tied closely to NRCS conservation practices, as you can see. And the plan was that we would increase our conservation on these landscapes and have both a positive impact on soils as well as the environment. But as you know, we had a change of administration, and even though this project was pretty far along and seemed to be a good way to approach things, it was tabled with the change that we had in our federal government. Well, over the past few years, there's really been a continued concern by producers on the impact of climate change and weather extremes on their ability to produce food and also support the farm economy. And so we saw a manifestation of that on the 2018 Farm Bill, that through this congressional action, one of the directives of this bill was to instruct USDA to increase our assistance to producers on adaptation and mitigation. So basically, there was signs of life, pushing things forward in the federal government to recognize the impact of climate change and then start. And just this year, then, USDA has initiated 2 initiatives to start increasing consideration of really what could be accomplished in this area. The first of the 2 is the USDA Science Blueprint. It consisted of several themes, or it does, of emphasis. One of these is climate adaptation. And what this directive from the Secretary did was bring together the staff of the USDA agencies to consider what additional research should be initiated to examine the strategies and practices to mitigate and build resilience to climate change. And this is an ongoing effort. In fact, this particular theme team we had a meeting just yesterday and trying to draw together some of the ideas from across different staff at USDA to actually make some changes. And also in 2020, there was a second initiative announced by the Secretary of Agriculture. This was in February as well, called the Agricultural Innovation Agenda. And you can see in blue the multiple themes that are being looked at. This particular one, they're trying to seek both public and private innovations to improve the environment as well as sustain profitability in farm and ranch. So while the blueprint was more targeted for research, this AIA agenda is really trying to seek new ideas, help farms and ranches. And you can see one of these that we're working on is called carbon sequestration and greenhouse gases. And what I find interesting and maybe a little amusing, that you can see the subtopics and that are being addressed. And to me, they're very similar to what we did with the USDA building block effort a few years ago. Unfortunately, we basically lost a little bit of time until we could kind of crawl back up in the saddle and start addressing some of these issues. Well, bearing in mind all this administrative activity, it really falls on our field office staff within USDA, extension agents, and others in the agricultural community to speak with landowners and to work with them. And so obviously climate change is a complex issue to discuss. And so it's important we find ways to effectively communicate these changes to farmers and ranchers so they can really be better prepared to adapt. So some of the ideas have been generated. One is that research has shown that perhaps the most important aspect of good climate communication is really to understand our audience and make sure we take time to listen to what they think and understand what's important to them. Very similar to what Martha was just relating. Each producer is unique, and you have to basically see what their individual goals and values are. And climate change connects across so many different topics. It's not just an environmental issue, but it's also related to human health, the economy, and national security. And if you understand what's important to your audience, you can tailor that message then and connect climate change impacts to the things that they really care about, whether they're wildlife or crop yields and such. And as it's stated, we really need to use clear terminology, avoid the scientific jargon. And while we recognize there's really a clear or strong consensus on climate change, a lot of people still see it as a political term, probably like wearing a mask. So certain audiences probably respond better if we use other terminology like weather variability and climate variability. Another idea is that most farmers don't see polar bears and melting glaciers in their day-to-day lives. So while changes in the Arctic are extreme and something we need to be worried about, using these sort of examples with farmers really makes climate change feel like it's a distant problem and gives people the impression that it's going to happen sometime in the future and not really an issue that impacts them during their lifetime. But we know climate change is happening now, and its effects are seen all across the globe, even in our own communities. And when we're discussing climate change with producers, we need to talk to them and use local relatable examples like the drought last summer or the extreme rainfall events they might have experienced in the spring. And we need to share our own experiences and real world examples. And we need to keep our messages hopeful. If we use scare tactics, that doesn't work to motivate change or any action. And so it's really important to stay positive and empower our audience by offering specific solutions and ideas for steps. And we got to make sure to emphasize that adapting to climate change is both necessary and positive. And simply having knowledge of a topic isn't usually enough to inspire behavioral change. But when this new information comes from a local trusted messenger, people are more likely to shift their perspectives and behaviors. And while people value what they value is generally most influenced by their local network, such as friends, neighbors, and peers, it's also possible for NRCS field staff and our partners who interact with these people to serve as a local, trusted messenger for this information. So we feel that, NRCS is in a great position to promote climate adaptation, because our field staff work directly with the community and regularly interact with landowners and farmers. And really for that reason, our staff might be ideal candidates for playing the role of the intermediary between, the producers as well as the scientists, climatologists, and land managers. Shifting gears a little bit, I'd like to talk about the USDA climate hubs and some of the resources and tools that have been generated by this team that impact farm adaptation. Well, the mission of the hubs is to develop and deliver science-based, regionally specific information to farmers, ranchers, foresters, and other stakeholders that really foster the communication of a productive and profitable agricultural system while conserving natural resources. And the hubs focus on 3 types of output. You can see there the assessments and syntheses, outreach and education, as well as technical support. And adaptation is one of our focus areas within the hubs. And these 10 hubs, they're composed of multiple USDA agencies, Forest Service, ARS, as well as NRCS. And we work to reduce the climate-related risks to agriculture, forestry, and rural communities by working with and through the USDA agencies as well as partners. So the hubs deliver and develop and deliver science-driven strategies and tools so that USDA programs, advisors, and land managers can really make more informed decisions about how to manage risk. Now each year, NRCS has 3 employees that are selected to spend a 1-year detail with a specific hub, and doing so, they work on a project of mutual interest. And it's really a great opportunity, as I've found, for our employees to get involved with the climate hub. So it's really people in the state or field office staff to sort of see what happens at a national level and get involved into a project and be able to spend the time on it and really have a positive outcome. Anyway, I do send a national bulletin out every September requesting applications from our staff. And then from that pool, the individuals are selected. And you can see the 3 folks shown here are my co-authors on the presentation, and then they are our current liaisons. Well, thinking about some of the tools, when we're working with producers, it's important to consider the impacts of climate change, and that issue can be addressed by using the principles of adaptive management to assist on-farm planning process. Adaptive management, it's a commonly used approach or tool. It's a flexible planning process, and it's been related to, within NRCS, the 9 steps of conservation planning. But it really just focuses on the impact of climate change and disruptive climatic events for on-farm planning. And so this process, it's an approach that's developed for agriculture by the staff of the USDA climate hubs as a tool for working with producers, extension personnel, USDA field staff, and other stakeholders. And it really turned out to be a fairly major product for the hubs. And Dan Dotsey, who was a liaison in 2016, was one of the lead authors for this publication. Now, it's termed Resources in Agriculture because it consists of several chapters on various aspects of climate change and adaptation. So each of the chapters can be viewed as a resource. But this resources isn't really about making recommendations for people to follow. Instead, it's really just a process to help farm managers and others organize information about their particular operation and expertise in a logical sequence, and then helping them develop their own customized adaptation actions. And the workbook supports diverse goals and actions And the climate hubs have spent quite a bit of time helping people use this workbook. We've done one-on-one sessions, we've had group workshops, and also there is an online tool as well available. Now, the workbook outlines a structured but flexible process for farmers and land managers to incorporate information about climate impacts and their assessments into specific farm management projects or actions. And this process it's purposely adapted because there's not a single adaptation response that they could use, and really the producers need to explore a variety of actions, and then they determine what they see as best fitting for their operation. And then from there, they evaluate what works, what doesn't work, and why maybe something failed and what they could do in the future. We always like to point out that this resource doesn't make recommendations for specific management actions. We don't tell people what to do, and it really doesn't, look or address climate-related risks such as finances and marketing. It focuses solely on just the risks of climate change. And then it does provide a lot of examples of actions that people could use, but we really don't endorse any number of them, or it's probably not a complete list of actions available because there's so many different kinds. But really the goal of the workbook is for the user to create really a clear rationale for why they're doing something on their farm, and then really connect that back to broader adaptation ideas. Now, here's a website at the bottom of this slide. From there, you can see that you have access to multiple adaptation menus that are available in addition to agriculture, so it can help landowners adapt to the impacts of climate change on a number of different topics or land uses. And so each one's slightly different, and it can help folks better look at adaptation for a number of issues. And another aspect of this project that we've really spent a lot of time on is to test the workbook on farms and ranches around the country. And this has really been an important process that allows us to work directly with the producers, but also then to test the workbook in the process to really figure out what's the best method of delivery and really what works well to communicate with these producers and then help them consider climate change actions. Well, beyond the workbook, there's we've had liaisons over the last 5 years who developed a number of products and tools in conjunction with the Climate Hub staff. Chris Miller, who's a New Jersey Plant Materials Center manager with NRCS. He worked with the Southeast and Northeast Climate Hubs last year on the issue of sea level rise and the impact of salinity on agriculture. And Chris examined adaptive management strategies to minimize the impacts of saltwater inundation on agricultural lands. So through all of his activities in the climate hubs, in 2019, the Southeast Hub held a workshop. They worked on assessment guidelines, and that does deliver and develop and deliver a number of options for producers on salt impacted soils. As a follow-up recently, the Southeast Climate Hub just released 13 commodity guides to help producers of various sorts prepare for and recover from hurricane events. And each of these guides begin with steps that producers can follow to build operational resilience to hurricane impacts, and then they are available for a number of different crops. And I might mention before we leave this is that Dan Kesey, our current liaison, is working on the economics of saline impacts on coastal regions as one of his projects. Well, in 2017, we had a liaison, Amber Wyndham. She was an NRCS soil scientist in Colorado, and her products were to produce 2 MLRA-based drought vulnerability assessments as she worked with the NRCS staff and the Southwest Climate Hub. And these drought vulnerability assessments were based on ecological sites and state and transition models. And they are designed to help landowners and government agencies identify and develop adaptation options for drought on rangelands. This assessment really does demonstrate or illustrates how site-specific information can be used to help minimize the effects of drought and support informed climate decision-making and when you go to select management adaptations. Another tool that's been produced down in that area, it's been released for about 2 years now, is GrassCast. And we know that every spring ranchers face the same difficult challenge, and that's trying to decide how much grass is going to be available for livestock to graze in the upcoming season. So the climate hubs and others have worked to produce this new GrassCast tool, and basically it's a result of the collaboration between ARS, the National Drought Mitigation Center, Colorado State University, as well as the University of Arizona, and NRCS has provided some financial support as well as a lot of review in this tool in order to bring it online. But what it does is it uses 30 years of historical data about weather and vegetation growth, and then they combine that with seasonal precipitation forecasts. And they want to predict if rangelands in individual counties will produce above normal, near normal, or below normal amounts of vegetation for grazing. And you can see, the tool started out in the Great Plains shown here, but it's now, they've expanded the information to go down in the Southwest United States. Stacy Clark, who was an NRCS liaison in 2019, she was an ecologist working out of Minnesota. She worked with the Northern Forest Climate Hub and also with NRCS Wisconsin staff to produce a number of two-page bulletins addressing the climate change impacts on forestry, wildlife, and wetlands. And then this year, Kristen Giesting, what she's working on is some similar products for the Midwest, looking at the impacts of climate change on croplands and livestock. And in addition, Kristen's working with a team to develop some agriculturally based climate summaries for the Great Lakes states. This climate mitigation handbook was recently produced, and the document was co-written by Steve Schmerick, our liaison, in 2018. And as well as others from the Southern Plains and Southwest Climate Hubs. And there was also information or chapters written by the staff at New Mexico State University, ARS, and NRCS. And what this resource does is it was developed to address the need for producers and specialists required to get some more information on in-depth solutions to specific dust and wind erosion problems. And the handbook was intended for resource managers at USDA and other land management agencies who are struggling with dust challenges and working with producers to craft solutions. And then finally, I'd like to mention the Tribal Scan Network. This was created by Suzanne Baker, who's a resource conservationist in New York and our Climate Hub liaison in 2017. As this is evolved, this is a continuing effort that's going on today, but it directly assists tribes in underserved areas by providing weather and climate information needed for agricultural production. And the installation process for these stations included both tribal members and NRCS staff working together to improve access to this technology and support sovereignty. So this really has been a team effort to get this off the ground. And you can see some of our collaborators beyond NRCS is BIA, universities, obviously the tribes are very much involved. We don't want to go out there and just install their station for them. We want them to be involved in the installation process. So they learn their equipment, they know how to maintain it, maybe ask questions when something's not working, and even replace some parts in the future. So this involves a lot of people working together to make things happen. And I can't let it go without giving my thanks to the National Water and Climate Center, Deb Harms, and the SCAN staff. They designed these tribal scan stations. They're about 1/3 of the cost of the full-blown scan sites. So they make them a lot more economical, and they're not quite as large and maybe not quite as complex, so folks can actually go out there and manage the installation as well as the maintenance on their own. But thanks to Deb in her role in Portland, and of course now she's at the Kellogg Soil Laboratory and the National Soil Survey Center as the national leader for the lab. And also, a big thanks goes to all the NRCS soil scientists. They have done a lot to keep this project moving. They've assisted in the selection and description of the sites and the soils, as well as conducting all the sampling that takes place on this. And I found out in a lot of cases, they're the ones that can either lead the station installation, or in some case, you know, they're part of the team in there trying to get these stations installed. So obviously without their help, again, we wouldn't have this project. And then, you know, the samples, they're sent to the National Soil Survey Center. The technicians in the Kellogg Soil Survey Lab run all the lab analyses, and the data is finally produced and placed online in their database. Now, in terms of making the tribal scan data available, obviously the data is sent to the National Water and Climate Center by cell phone modems. There and goes some QA/QC and then made available to users online at the website there, that you can see at the right on the slide. But in the midst of all this, we decided to create a second website. We worked with Art Degatano at Cornell University and the Northeast Regional Climate Center to develop some decision tools for Soil Climate Analysis Network. And in doing this, they take the data from the National Water and Climate Center, they download it at Cornell, and they're taking both scan and tribal scan data. So they're building tools then that makes it the data more usable for farmers and ranchers. And so just to show you a couple examples of you know, what we have, this is the weather grapher tool from the NOVA site. And you can see the plots of soil and air temperature, precipitation, and soil moisture. So there's other plots you can have. This is just some small ones. Also, the growing degree day calculator. That's a fairly common tool, and that's been produced and is available on this website as well for all the scan and tribal scan data. And currently, as things stand, we have 16 stations installed and 7 more delivered, and hopefully they can be installed by the end of the year. Obviously, COVID has been a real problem for getting out in the field and access to tribal lands. But we do have one in Colorado that looks like it's going to take place under certain restrictions and, you know, social distancing and limited field staff and that sort of stuff. But we'll try to get them in as best we can. But again, the installation's a cooperative project and process. And one good thing is the National Water and Climate Center SCAN staff developed this installation manual. And it's great. And I even found that I can go out and install a station reading the manual. So I think that's a pretty good sign about anybody else could do it as well. Well, in conclusion, you know, just want to say that climate change is recognized by USDA as an important consideration of agricultural productivity and resilience. I've just noticed over the last few years, you know, we went from sort of panic at the beginning of our new administration that we couldn't even really worry about climate change to, in fact, now USDA has recognized it and is moving forward to try to work with producers and others in order to build some sort of consideration and build the tools necessary. And so it really does bode well for the climate hubs to, stay alive and keep moving forward. Obviously, as the climate continues to change, we're going to need tools that connect the agricultural issues to solutions. And so one thing the climate hubs do is try to take some real research type information that might be released as scientific publications and build tools or usable information for farmers and ranchers. So that's a big effort from everybody. But anyway, we're trying to work together to develop these products and assist farmers, ranchers, and other forest landowners. And with that, I'll thank you for your attention, and I'm happy to answer any questions you might have.
Thanks, Mike. Jen, is there any questions for Mike? Hey,
There
Jen?
is not at this time.
Okay, well, just send me an email if
Okay.
anybody has any questions.
So I'm going to go ahead and wrap up. Okay, this wraps up the morning session. We have a break for lunch from 11:30 to 12:30. Is that correct, Jen?
That is correct.
Okey-doke. And we have a lineup of speakers. And then after the speakers, we have the breakout sessions. So we'll see everybody back here at 12:30 Central Standard Time.
If you are a speaker that is coming up within the next session and you are online, I see a couple of you. You can check back in with us to test if you haven't already, or send me a private message and we can run through some testing if you would like.